This is part 2 of lesson 8.3, angles of rotation. Okay, picking up where we left off, we've done 7 and 8, which we had a specific point P. Now what we're going to do is we're going to find a general case. So if P is x, y, that means it can be anything. So we're doing a general rule. Okay, we're going to make this rule that will be true for all of our situations. So xy, so I'm just going to take something in the first quadrant because since the reference angle is always positive, it doesn't really matter which quadrant as far as that goes. The x and the y will be reflected in the positive and negative signs, but this is going to be our x and this is our y. I'm going to call this r. Okay, and we'll talk about why I'm calling it r later, but I am. Well, actually, I'll tell you right now. So if I was taking this angle, if I started right here, if I was to rotate it all the way around, it would make a circle, and this would be my radius. And so that's why we call it r, because we are dealing with situations where a circle can be provided there. So we're going to call that r, but we're only talking about this being our center, this is theta, this point is the ordered pair x, y. Okay, so in that situation, if theta is my angle right there, my angle of reference, the cosine is adjacent over hypotenuse, so that would be x over r. So using that model, can you fill in the rest of the 5 questions? So pause the video and see if you can fill in the rest of the 5. Okay, you should have said r over x is secant because it's just the inverse. Sine would be opposite, which is y over hypotenuse, which is r, and so cosecant would be r over y. And then tangent would be opposite, which is y over adjacent, which is x, and cotangent then would be x over y. So this is our general rule. So anytime you have a point, x, y, you can find the cosine, secant, cotangent, whatever. You can find that using that rule. And you don't have to memorize it or anything, but that's just something that you can go back to if you need it. So let's look at a couple of situations here. So number 10, the terminal side of theta, now it says in standard position, and that's important because it means it starts right here, okay? It's in quadrant 2. That's important because it tells us about the positive and negative signs of x and y. So if it's in quadrant 2, we know that we're right there. Now as far as exactly where in quadrant 2, it doesn't really matter because we're going to just base it on a general rule. So this is going to be our x and y. Okay, and so then if I'm saying this would be my angle theta then, because that's the reference angle, and this would be my triangle. So really when you're doing this, you need to be able to focus in, zero in on that special triangle right there. Okay, that's what we're looking at. Now it tells us a clue. It says that the cosine is negative 3/5. In this quadrant, I know that my x is going to be negative, and I know that y is going to be positive. This is going to be r. If you think about the Pythagorean Theorem, if you did negative x and you squared it plus y squared, r is always going to be positive. So r is always positive. X and y, depending on what quadrant they're in, they might be negative. Okay, so I've got the cosine, which I know is adjacent, which is x over hypotenuse. And so I know that the r can't be the negative, so the x has to be the negative. So this is going to be negative 3. And then the radius, or the r, has to be 5 because that's what this is telling me. So I know that this is 5. Given that information, can you find what y is? Using the Pythagorean Theorem. So I can say negative 3 squared plus y squared is equal to 5 squared. And so y squared is equal to 25 minus 9. So y would have to be 4. And so using that, now I can find all the rest of them. So I know the secant would be the inverse, so negative 5/3. The sine, remember this is my angle, so my sine is going to be 4 over 5. Another way you can do it is you can say x is equal to negative 3, y is equal to 4, and r is equal to 5. You can just use this rule that we had before from our previous problem. So you can do that if you have that handy. Personally, I find it's easier to just do this triangle and just do that. I don't like to memorize rules and stuff. So that's how you would do that. Tangent would be opposite over adjacent, so that's y over negative x. So that's 4 over negative 3, and then cotangent would be the inverse of that. So on your quiz, on your test, you're going to be asked to do that for a point, like we did on these, on the previous problems before number 9, I guess, before, like on 7 and 8, like you had to do there. You're also going to be asked to find the different ratios if I give you one of them. If I give you one of them, can you find the rest of the ratios? So before you do your quiz, you want to make sure that you really understand how to do those problems on the homework. So make sure you ask if you have a question. Okay, number 11, this is the last one. So I'm going to just talk you through the setup of it, and then I want you to pause the video and go and finish it. So it says the terminal side of theta in standard position is in quadrant 3. So in quadrant 3, so it goes 1, 2, 3, 4. And so quadrant 3 is going to be down here. So what that means, it means that my reference angle will be right there. Okay, whoops, that's not a very good line. My triangle is going to be this right here. It means my x is going to be negative and my y is going to be negative because you're going left and down to get to this point. R is always positive. Now because this is sine is opposite over hypotenuse, so that's y over r. So I know that y is equal to negative 1 because r can't be the negative. R is equal to positive 2. And so I just need to use the Pythagorean Theorem to find x. So I don't know that one, but I do know that this is negative 1 and I know that this is 2. So you can find what x is. So negative 1 squared plus x squared is equal to 2 squared. So x squared is equal to 3. So x is equal to the square root of 3. So x equals square root of 3. So where this is as far as your graph goes, that would mean that this is negative square root 3, and this is negative 1, and this is 2. So this ordered pair P right there, that ordered pair would be negative square root 3, comma, negative 1. Now as far as finding all of your trig ratios, we're given sine, so that should be easy. Because you're given sine, all you have to do is do the inverse to get cosecant, so that's negative 2 over 1, which is just negative 2. To get the cosine, it's going to be adjacent, or x, over r. And so x is negative square root 3 over r, and the secant is the inverse of that. Remember, it doesn't matter where your negative sign is. Tangent is going to be y over x, or opposite over adjacent. So y over x is going to be negative 1 over negative square root 3, so that's going to be a positive 1 over square root 3. Again, you do not have to simplify the radicals. I'm okay if you just want to leave it like that. And then the inverse of that would be square root 3 over 1. So make sure that you understand that. Make sure you're careful with your signs, because if you say positive and it should be negative, then obviously that's wrong, because that would mean it's in a different quadrant. So if you're in the wrong quadrant, you're not giving the right answer. So make sure you understand that. Bring your questions to me and I will be happy to work with you to help you understand that more. And we are now at the end of the lesson.